In the heart of Chile's Atacama Desert, the ground is so dry, so utterly alien, it is used to test the rovers we send to Mars. This is the driest, non-polar place on Earth. Some weather stations here have never recorded a single drop of rain. It is a landscape of rust-colored dust and salt flats, a silent world seemingly devoid of life. But then, a planetary signal arrives, and this sterile, Martian-like expanse does something impossible. It explodes into a vibrant carpet of millions of flowers, a phenomenon so breathtaking it is called the desierto florido. The flowering desert, an event that defies all logic, turning the world's driest wasteland into an ephemeral paradise. The Atacama's extreme nature is no accident. It is engineered by immense geological forces. To the east, the towering Andes Mountains create a formidable wall. They scrape all moisture from the air flowing west from the Amazon basin. To the west, the smaller Chilean coast range does the same, blocking fog and humid air from the Pacific. This is a double rain shadow, a fortress against water. But there is a second, more powerful barrier. The cold Humboldt Current, flowing north from Antarctica, chills the air along the coast. This creates a thermal inversion. A stable lid of cool air sits below a layer of warmer air, preventing clouds from rising and forming rain. For years, even decades, this atmospheric lock holds the desert in its arid grip. To understand how this lock is broken, we must zoom out, far out, across the entire Pacific Ocean. Here, a colossal engine of heat and water governs weather patterns across the globe. It is a planetary rhythm known as the El Niño Southern Oscillation, or ENSO, a force powerful enough to reach into the heart of the Atacama. Under normal conditions, strong trade winds blow from east to west across the Pacific. They push warm surface water toward Australia and Indonesia, creating a deep pool of heat in the Western Ocean. Meanwhile, off the coast of South America, the cold, nutrient-rich water of the Humboldt Current dominates. But every few years, this entire system falters. The trade winds weaken, or even reverse. That immense volume of warm water, no longer held back, begins to slosh eastward across the Pacific. This is an El Niño event, a massive redistribution of the planet's heat energy. As this wave of warm water reaches the coast of South America, it collides with the cold Humboldt Current. The temperature difference is immense. The warm, moist air from the ocean overrides the cool, stable air that normally blankets the coast. The thermal inversion, the desert's invisible shield, begins to weaken and break apart. Suddenly, the atmospheric barrier is gone. The southern storm track, which typically stays far out to sea, is able to shift northward. For the first time in years, moisture-laden air masses can finally push inland. They rise over the coastal mountains, cool, and release their precious cargo. Rain falls on the Atacama. But water alone does not create the desierto florido. The true secret lies beneath the dust, at a microscopic scale. The desert floor is not dead. It is a living library. A seed bank containing the genetic heritage of over 200 unique plant species, waiting patiently in a state of suspended animation. Each seed is a time capsule coated in a layer of chemicals. These are germination inhibitors. They function as a biological lock, a complex mechanism designed by evolution to prevent growth until the conditions for survival are not just good, but perfect. So what is the key? What precise environmental signal is powerful enough to turn this ancient lock and awaken an entire desert from its slumber? The trigger is far more specific than just the presence of water. A light drizzle is actually a trap. It would coax a seed to sprout, only for it to wither in the returning sun. The seeds are patient. They wait for a guarantee. That guarantee arrives as a specific quantity of rain. The event requires a downpour of at least 15 millimeters. This threshold is crucial because it's enough moisture to physically wash away the germination-inhibiting chemicals from each seed's outer shell, finally unlocking its potential. When this threshold is met, the transformation begins. It is staggering in its speed and scale. The desierto florido is not a slow awakening. It is an explosion of life. The barren, monochromatic landscape of red and brown earth simply vanishes. It is completely overwhelmed by a living carpet of color, as millions of flowers erupt from the dust, seemingly all at once. This breathtaking spectacle is defined by iconic species. The ground becomes a sea of vibrant pink from the Pata de Guanaco, punctuated by the rare deep red of the Garra de León, a flower that exists nowhere else on Earth. But this flowering is not just a botanical event. It is the starter pistol for an entire dormant ecosystem. The sudden massive supply of nectar and vegetation awakens legions of latent insects and larvae that have been buried in the soil for years. This, in turn, provides a feast that awakens a whole food web. Lizards emerge from the sand. Rodents, like the Darwin's leaf-eared mouse, appear from their burrows, and this abundance of prey attracts predators, foxes and birds of prey that materialize from a silent landscape. And this is the core revelation. The desierto florido is not an anomaly. It is not a disruption to the desert's quiet existence. The barren, dusty landscape we see for years is merely the dormant phase, the long, patient pause in the desert's true life cycle. This reframes the entire desert. It's not a dead place waiting for a miracle. It is a living system in a state of deep, patient slumber. But a crucial question remained. How does a seed, buried for a decade, know the difference between a fleeting shower and a life-giving El Niño event? The answer is an elegant, two-part security system. The first trigger is, of course, water. But not just any amount. The rainfall must be significant enough to wash away the germination-inhibiting chemicals coating the seeds. This is the first key turning in the lock. It ensures the seed doesn't sprout after a minor, unsustainable drizzle. But the second trigger is the true genius of this adaptation. Temperature. A true El Niño event doesn't just bring rain. It also significantly warms the coastal Pacific waters. This, in turn, raises the ambient air and soil temperature in the Atacama. The seeds will only germinate when they experience both the chemical wash from the rain and a sustained period above a specific temperature threshold. This dual trigger mechanism is a masterpiece of evolutionary risk management. It is an incredibly high-stakes gamble. If the seeds were to germinate after a small, insufficient rain without the corresponding temperature shift, the entire generation would perish in the returning heat. Decades of stored genetic potential would be lost to a false start. The system is nature's equivalent of a lock requiring two separate keys, turned at the same time. This biological safeguard ensures that the desert's hidden life only awakens when conditions are truly optimal for a full life cycle. It is the ultimate strategy for survival in a land defined by its hostility to life. Now, zoom out from the microscopic seed to a planetary perspective. The desierto florido is one of the most beautiful and direct visualizations of Earth as a single, interconnected system. It is tangible proof of a global connection. A subtle temperature change in the Pacific Ocean, thousands of miles away, sets in motion a chain of atmospheric events. This chain culminates in a field of millions of flowers blooming in the driest place on Earth. The phenomenon transforms an abstract climate pattern into a breathtaking, living spectacle. This raises a profound question for our time. As human activity alters global climate patterns, what is the future of this delicate phenomenon? Scientists are now actively researching how changes in the frequency and intensity of El Niño events will impact the Atacama's bloom. Will a warmer world lead to more frequent, more spectacular flowering events? Or could the disruption of these ancient climate rhythms push the system past a tipping point, breaking the delicate two-key mechanism? The flowering desert is no longer just a symbol of resilience. It is now a sensitive barometer for the health of our planet's interconnected systems. Yet this entire breathtaking system exists in a delicate balance. A warming planet introduces profound uncertainty. Shifts in ocean temperatures could alter the frequency and intensity of El Niño events. The very trigger for this explosion of life is now subject to unpredictable change. This vulnerability extends beyond just the rain. Altered climate conditions could favor invasive species, plants not native to the Atacama. These newcomers, unaccustomed to the desert's harsh rules, might outcompete the native flowers for the brief window of water and nutrients, threatening the integrity of this unique floral spectacle. So, the desierto florido becomes more than just a regional marvel. It is a planetary barometer. The health of this bloom is a direct reflection of the health of the Pacific Ocean, its vibrant colors, or its silence. Tell a story about the immense, interconnected systems that govern our world's climate. This phenomenon forces us to redefine what a desert truly is. The Atacama is not empty. It is not dead. It is waiting. It is an ecosystem built on the foundation of patience, holding immense potential energy in reserve, ready to be unleashed by a signal from half a world away. And between these rare, life-giving rains, another subtle force is at work. The Camanchaca, a dense coastal fog, regularly rolls in from the Pacific. This fog is a critical source of moisture. It doesn't trigger germination, but it sustains the microscopic life in the soil, keeping the seed bank viable through years of punishing drought. Visualize this: tiny droplets of water from the Camanchaca condensing on a single grain of sand. Now multiply that by trillions. This is not a storm, but a quiet, persistent breath of life. It's a lifeline delivered not by rain clouds, but by the air itself, sustaining the potential for the next breathtaking bloom. But this raises a crucial question. Is it just water and temperature, or are there other, more subtle triggers we have yet to discover? Scientists wonder if the unique mineral composition of the Atacama's soil, washed down from the Andes, plays a role in signaling to the seeds that conditions are perfect for their high-stakes gamble. The extreme survival strategies of these desert plants have captured the attention of astrobiologists. The Atacama is one of the best Earth-based analogues for the surface of Mars. By studying how life persists and revives here, scientists learn what to look for when searching for signs of past or present life on other worlds. Ultimately, the flowering desert is a profound story of hope. It is a powerful, visible reminder that life's resilience is often hidden from view, that even in landscapes that appear utterly desolate, there exists a deep, patient, and powerful capacity for renewal. And so the cycle continues. The flowers will soon fade, their petals will fall, and their seeds will return to the dry earth. They will once again become a dormant promise, entrusting their future to the vast, complex rhythms of the planet, waiting for the ocean to call them back to life.